The James Webb Space Telescope is humanity's most powerful eye in the sky, a giant golden honeycomb floating a million miles from Earth. Its main job? To look back in time. Because light takes time to travel, Webb sees distant galaxies as they were billions of years ago. Webb is designed to see infrared light, invisible to us but rich with secrets about the early universe, newborn stars and distant planets. Its 21-foot wide mirror, made of 18 gold-coated hexagons, collects faint light from the farthest reaches of space. A massive sun shield, the size of a tennis court, keeps the telescope cold, blocking heat from the sun, Earth, and Moon. Unlike Hubble, Webb orbits the Sun at the second Lagrange point, a million miles from Earth, ensuring a stable, deep-freeze environment. This lets Webb stare at a single spot for long periods, gathering every possible photon to reveal the universe's hidden history. Webb's mission is ambitious, to answer how the first stars and galaxies formed, how planetary systems emerge, and whether life exists on other worlds. By studying exoplanet atmospheres, Webb searches for the chemical building blocks of life. Already it's rewriting our cosmic textbooks with every breathtaking image. Webb is our premier instrument for exploring the unknown. It's a revolutionary tool, changing how we see the universe. And it's just getting started. Now meet our special guest, 3I/Atlas. The I stands for interstellar. This object isn't from our solar system at all. Born in another star system, 3I/Atlas was ejected into the void and wandered for millions, maybe billions of years before entering our neighborhood. Spotted by the Atlas survey, its hyperbolic path means it'll swing by the sun once, then vanish forever into interstellar space. This makes it a rare, one-time opportunity for study, a true alien visitor. Our solar system's objects share a common origin, but 3I/Atlas is a direct sample from a distant, unknown environment. Before this, only two other interstellar visitors were confirmed, Oumuamua and 2I/Borisov, each with their own mysteries. 3I/Atlas is the third, and it's brought a whole new set of puzzles. Studying its composition lets us compare the chemistry of other star systems to our own. Each interstellar object is a cosmic lottery ticket, offering clues about the diversity of worlds in our galaxy. With 3I/Atlas, we've hit a scientific jackpot. It's a fleeting chance to learn about the galaxy beyond our reach. Let's see what secrets it holds. When 3I/Atlas appeared, astronomers pointed the James Webb Space Telescope at it, our best tool for the job. As it neared the sun, the object's surface warmed, releasing gases and dust to form a temporary atmosphere, or coma. This coma acts as a chemical fingerprint, revealing the object's inner composition. Webb's powerful infrared spectrograph, NIRSpec, broke down the coma's light into a spectrum, a cosmic barcode. Each element and molecule leaves unique marks in the spectrum, letting scientists identify what's present. The observation window was brief, so astronomers had to track 3I/Atlas with precision as it sped through the solar system. The goal: capture the most detailed spectrum ever taken of an interstellar object. Scientists expected to find familiar comet ingredients, water, carbon dioxide, maybe some organics. But Webb's data revealed something extraordinary. Among the usual signatures, there were bright, unexpected emission lines glowing in the infrared. The team double-checked their data. This was no mistake. Webb had detected a signal that would challenge everything we thought we knew about these cosmic visitors. The surprise? Webb's spectrum showed not just water or carbon compounds, but metals, iron and nickel, glowing as gas. This was shocking. Metals like these shouldn't vaporize so far from the sun, where it's freezing cold. Normally you'd need to be much closer to a star to see metals in a gaseous state, yet Webb's NIRSpec instrument picked up clear, sharp peaks for these heavy elements in the coma of 3I/Atlas. It was as if the object was venting a cloud of hot metallic gas into space, something never seen from a comet at this distance. The temperature was far too low for metals to sublimate, so what was causing this? Something unusual was heating these elements, releasing them as gas. This wasn't gentle sublimation of ice, it was something far more energetic. The discovery set 3I/Atlas apart from any comet in our solar system. Scientists were stunned. This was a dynamic, complex body, not just a frozen ball of rock and ice. The glowing metals were a flare, signaling a mystery from another star system. 3I/Atlas was far more interesting than anyone had imagined. The investigation had just begun. So, what did Webb actually find? The spectrum revealed a cocktail of metals, iron and nickel most prominent. These are the same elements that form the cores of rocky planets like Earth, but finding them as gas in a cold comet's coma was a huge surprise. The amounts were significant, far more than could be explained by dust breaking apart. Webb also detected hints of chromium and manganese, elements found in metallic asteroids and planetary cores. It was as if a fragment of a planet's deep interior had been set adrift in space. The ratios of these metals didn't match anything in our solar system, meteorites, asteroids, or even Earth. This suggests 3I/Atlas's parent body formed in a very different environment. In our comets, metals are usually locked in dust and only vaporize when extremely close to the sun. 3I/Atlas was nowhere near that close, yet it was spewing gaseous metals. Webb's sensitivity forced scientists to rethink what's possible on these cold, wandering bodies. The metallic emissions were a clear sign. Our assumptions were about to be broken. 3I/Atlas was rewriting the rules. Gaseous metals in 3I/Atlas defy our basic understanding of comets. Comets are dirty snowballs, ice, dust, and rock, with activity driven by the sun's gentle heat. Iron only vaporizes at over 5,000 degrees Fahrenheit, but 3I/Atlas was far from the sun, in deep freeze. Sunlight alone couldn't explain the metallic gas, something else was at work. Maybe a recent collision or internal explosion created a burst of heat, releasing metals as gas. The fact that Webb saw them glowing means this was a recent active event. 3I/Atlas isn't just a passive traveler, it's dynamically active. Its emissions blur the line between comet and metal-rich asteroid. Interstellar objects are proving to be stranger and more diverse than we ever imagined. 3I/Atlas is perhaps the most unique one yet. The metals, iron, nickel, chromium, are powerful clues to 3I/Atlas's origin. These refractory elements usually sink to the core of large bodies during planetary formation. Their presence suggests 3I/Atlas came from a differentiated parent, maybe a planetesimal or small planet with a metallic core. A violent impact could have shattered that world, flinging fragments like 3I/Atlas into interstellar space. This fits the evidence, a metal-rich composition and the energy needed for ejection. The metallic emissions might be a lingering effect of that ancient trauma. As the object warms, energetic reactions could create hotspots, vaporizing metals. The glowing gas tells us not just what 3I/Atlas is made of, but the violent story it carries. It's a messenger from a shattered world. Let's reconstruct 3I/Atlas's journey. Billions of years ago, it formed in a distant star's disk, growing large enough to develop a metallic core. A catastrophic collision shattered this young world, mixing its core and mantle. One fragment, 3I/Atlas, was ejected into interstellar space. For eons it drifted silently, bombarded by cosmic rays, its chemistry slowly changing. By chance it entered our solar system, warming for the first time in ages. The heat activated energetic materials from its violent past, creating hotspots that vaporized metals. A faint, glowing cloud of metallic gas trailed behind it. At that moment, Webb was watching, capturing the light from this unique event. For a brief time, we witnessed the echoes of a world's destruction from another star system. 3I/Atlas became a cosmic storyteller. The discovery of metallic emissions from 3I/Atlas has opened a new frontier. Scientists are analyzing Webb's data, searching for more elements and refining abundance measurements. Observing how emissions change as 3I/Atlas cools will reveal more about the mechanisms at work. Every photon gathered before it fades is precious. The ultimate goal: find more interstellar objects. Surveys like Atlas and the upcoming Vera Rubin Observatory will help us spot more of these cosmic visitors. Each one is a chance to study the building blocks of other solar systems. 3I/Atlas reminds us the universe is full of surprises. By studying these messengers, we learn about the diversity of worlds and our own place in the cosmos. The story is just beginning.